Good morning to everyone. I welcome you all for another lecture on the course Microprocessors and Microcontrollers. In today's class, I would like to discuss about the concept, the architecture of 80386 processor. So, 80386 possesses the ability of a three-stage pipeline. So, this we can understand once we can go and see the structure of 80386. I think everyone aware of that 8086. The 8086 architecture is divided into two partitions. One is a bus interfacing unit and second one is execution unit. So there we identify that two-stage pipeline. In a similar way, if you are coming to 80386, its architecture may look like it may support a three-stage pipeline. Those three stages are instruction fetching, instruction decoding, and then instruction execution. Once a structure supports this pipelining concept, there is no doubt the speed of operation of your processor increases. So, thus all these units operate in parallel. That means fetching unit, decoding unit, and execution unit. These three units are operate in parallel, so that the pipelining technique leads to reduction in overall processing time, thereby increasing the performance of overall system itself. So once we can go and operate these three stages in parallel, automatically there are three instructions are in pipelining. One instruction is at execution stage, and the next instruction is at decoding stage, and another instruction is at fetching stage. So there are three instructions are in the pipelining and three instructions are in the execution process in parallel, so that the speed of operation of the system is increases. Now we can go and see the architecture of 80386. See here friends, this is the architecture of 80386. This whole 80386 architecture I divided into 6 different partitions. I repeat, this whole architecture of 80386 is divided into 6 different partitions. So, this is my first partition, which I can call as bus interfacing unit, that is a BIU, and second one is code prefetch unit, and third one is instruction decode unit, fourth one is execution unit, and coming to fifth one is segmentation unit. This is a segmentation unit, and this one is called a paging unit. So like this, there are the 6 different partitions are exist in the architecture of 80386. So I repeat once again, the first one is bus interfacing unit, second one is a code prefetch unit, third one is instruction decode unit, fourth one is instruction execution unit, fifth one is segmentation unit, and the last, sixth one is a paging unit. Here interesting thing is, the combination of segmentation unit and paging unit we consider as memory management unit, MMU. So this is the architecture of 80386. Now I am going to discuss these units one by one in detailed way. Right. So again I written the same thing, that is architecture is divided into 6 partitions: bus interfacing unit, instruction prefetch, code prefetch unit or instruction prefetch unit, or instruction decode unit, instruction execution unit, segmentation unit, and then paging unit. So I already told you the combination of these two we call as MMU, that is memory management unit. And coming to these 3, that is code prefetch unit, instruction decode unit, and then instruction execution unit. These are 3 units we can call as central processing unit, CPU. And as usual, the first one is bus interfacing unit, and simply we are written as BIU, bus interfacing unit. That means if I divide this whole architecture into 3 different sections, first section is BIU, second section is CPU, and third section is MMU. These are 3 sections I divided into 6 partitions. My first partition is bus interface unit, second one is code prefetch unit, third one is instruction decode unit, fourth one is instruction execution unit, fifth one is segmentation unit, and then sixth one is paging unit. Now I am going to discuss these parts one by one. First, I start my discussion with the bus interfacing unit, BIU. What this BIU can do, the name itself indicates bus interface unit. I can share about this particular unit an important single statement like this. With the help of this BIU only, our 80386 can communicating with external world. That means your 80386 can communicating with either memory or it can be communicating with the memory elements with the help of only this bus interfacing unit. That you have to remember, friends. Now, the first point is like this. It can handle the data transfer between a processor, memory, and then I/O devices. That means your processor 80386 can communicating with the memory or with the I/O devices with the help of this bus interfacing unit. And coming to the second thing, 80386 supports 8 bits, 16 bits, and 32 bits data transfers, because we know that our 80386 has 32 data lines. With the help of the 32 data lines, at a time it can transfer or receive 32 data bits maximum. Sometimes if your operation is done on 16 bits, then it can read or write 16 bits at a time, 2 or from I/O devices or from memory elements. That case we are using 16 bits. And sometimes your processor may also do the operation on 8 bits, then your processor may transfer or receive 8 data bits. Right. BIU holds a 32-bit bidirectional data bus. That means with the help of these 32 data lines, your 386 can transfer or receive a data. And as well as it has a 32-bit address bus. So before transferring a data or before receiving a data to or from an I/O device or a memory, what first my processor can do is it will generate an address. The address of an I/O device or an address of a memory location. Whatever the address my processor can generate, that address carried by these 32 address lines or 32-bit address bus. So your 80386 has 32-bit bidirectional data bus and 32-bit address bus, which is unidirectional. Right. Whenever a need for an instruction or a data fetch is generated by the system. So when I was used this BIU, for what purpose I was used this BIU? So I get an answer for that. It is wherever I need an instruction from the memory or where I need for execution of an instruction a data, then my system inform that information to BIU, then BIU go and get a data from a memory or from an I/O devices. Alright. Next, then the BIU generates signals for activating the data and address bus in order to fetch the data from desired address. So I already told you, if I want to read something from a memory or from an I/O device, the first of all my processor has to generate an address. So after that it will generate a required control signals. Here my operation is read, so it will generate a read signal. Then it will go and read a data from my selected location or a device with the help of this bus interfacing unit. Fine. And coming to the next thing is, it has a prioritizer to resolve the priority of the various bus requests. Because there are different requests that will be received by BIU from the internal structure of 80386. Out of all those requests, it will assign some priority order according to that one only. What are the signals those are needed to communicating with the external world, those can be activated by your bus interfacing circuit. So, that's the use of this. This processing unit contains the latches and drivers for an address bus. So, if you are observing our bus interfacing unit, it will consist of some address drivers. These address drivers are only dedicated for an address bus. So, in order to drive my address bus, I need a drivers. So, those are exist. So, this processing unit contains the latches and drivers for an address bus. And similarly, for a data bus, I have a transceivers. So, what a transceiver? A transceiver is nothing but a transmitter or a receiver. That means it is a bidirectional buffer itself. So either the data was transferring from processor end to other end, or your processor can go and receive a data from other end. So that is do with the help of a data bus. So whatever the data we are transferring to external world, or whatever the data we are receiving from the external world, that I do with the help of this transceivers or a bidirectional buffers. These are also present in my bus interfacing unit. And next, the control logic for signaling, where a memory, input and output or interrupt acknowledgement bus cycle is to be performed. That means if I want to do my operation is related to memory or my operation is related to I/O, what a control logic can do is it will generate the required control signal which is necessary for the operation what we are going to perform. For example, if I want to do a read operation on a memory location, so that my control logic circuit may generate a read signal. If I want to do a write operation on some output device, then my control logic may generate a write control signal which is I must send it to an I/O device. So based on what an operation my processor want to perform on a selected device or a selected memory location, the required control signals are generated by the control logic. Again, it is a part of my bus interfacing unit. The address driver drives the bus enable and bus signals, that is A0 to A31. The pipeline and dynamic bus sizing units handle the related control signals. So all these things are present in my bus interfacing circuit along with these different signals. Fine. Coming to the next one is code prefetch unit. What's the use of this prefetch unit? So one thing you remember, friends, what are the instructions I was going to read from a memory? Those instructions I stored in this instruction or a code prefetch unit. So I already told you that your 80386 possesses 3-stage pipeline. That means there are 3 instructions are in processing. One instruction is at execution, second one is at decoding, and the third one is at fetching. So in advance only, what are the instructions we are going to execute in your future? Those instructions I fetched from the memory and those I can store down to this prefetch unit. So what it do? It is used to fetch the instructions in advance. That is, while the execution unit executes the current instruction. If it executes some current instruction, what are the instruction your execution unit is going to execute the next? That instruction we are going to fetch from the memory in advance itself. Those instructions I can store onto this instruction or code prefetch unit. Coming to the second one, the prefetch unit fetches that instruction from the memory and stores it in 16-byte prefetch queue. It is very important, guys, because if you refer 8086 architecture, in 8086 architecture also we have prefetch queue of size just only 6 bytes. So what are the instructions your 8086 can execute at a time? Those instructions advance only they can fetch from the memory. Those instructions are stored onto that prefetch queue of size only just 6 bytes. But if I come into this case, the queue size was increases to 16 bytes. That means I can go and store more instructions compared to 8086 prefetch queue. So once if I store more instruction on a prefetch queue, continuously I can supply the instructions to an execution unit so that my CPU can't entering into wait state. So from that I can get whatever the advantage that I was expecting from my processor. That is, it is always is in continuously a running condition. So here the queue size is equivalent to 16 bytes. So 16 bytes of instruction ahead we are going to fetch from the memory. Those I was stored onto this prefetch queue. So that is very important. The sequence in which the instructions are fetched and get stored in queue depends on the order they exist in the memory. What order we are fetching the instructions from the memory. In that same order, I'll go and copy my instructions into prefetch queue. From there only, my instruction is transferred to the next stage, that is an instruction decode stage. That means my queue operating principle is fast in, fast out. So what the instruction first entering into instruction prefetch queue, that instruction first leaves from queue itself. So that's the meaning of this particular. Finally, what I conclude about this particular unit is, this is a unit very helpful for me what are the instructions I was going to execute in near future, those instructions I was fetching from the memory, and those instructions I simply copied onto my prefetch queue of size 16 bytes. So that's the meaning, that's the use of this particular unit itself. And coming to the next one is instruction decode unit. What this instruction decode unit can do? So the name itself indicates this unit decodes what are the instruction was going to execute by execution unit next. It will go and fetch the instruction from your code prefetch unit, or your instruction decode unit going to get an instruction from instruction or code prefetch unit, and that instruction it will go and decode. So here the meaning of decoding is identification of operation as well as identification of operands. So that decoding process I was doing in case of this instruction decode unit simply. Now we can go and see. This unit is responsible for decoding the output received from the instruction. So what was the instruction I was receiving from my code prefetch unit? That instruction must be decoded. In the decoding process, I have to go and identify what my operation code was. That indicates what my operation and what my operands are. That means the operation is performed on which operands. So that's it. The decoding unit accesses the output end of prefetch unit's instruction queue. That's what I'm saying. Your instruction decode unit get the instruction from code prefetch unit or instruction prefetch unit. So what all the instructions we are fetching from the memory, those we are stored onto prefetch queue. From that one only the instructions are collected by this instruction decode unit. Next, the instruction queue, a part of a decoding unit, permits 3 fully decoded instructions to be held waiting for use by the execution unit. So the important thing is this instruction decoding unit also contains a 3-stage or a 3 fully decoded instruction queue. So it has also a QSXS, which is called instruction decode unit, have a queue. That queue can hold a 3 bytes or a 3-stage our decoded instruction, it can hold it. So what all the instructions are stored in that queue, those are decoded instructions one by one, it is supplied to the execution unit. That means you remember friends, you may found the queues both in a code prefetch unit where the size is equal to 16 bytes, and second one is you may found in a queue it is also in instruction decode unit, but here the size is only a 3 byte. So that's the meaning of this. This improves the performance of the CPU. That's fine. And next, coming to the fourth part of your architecture, which is instruction execution unit. So this instruction execution unit get the instruction from the queue of our instruction decode unit. So what are the instruction we are decoded in instruction decoding unit? Those instructions are executed in execution unit. That means the instruction which operation you want to perform and which operands, those operations are performed in this execution unit. So in this execution unit have a different partitions like ALU and a group of registers, and we have a multiply and divide unit, and we have a barrel shifter, as well as it has a control ROM. So these are the major parts you may found in execution unit of 80386. Now we can go and discuss much more about the functionalities of these partitions which are present in execution unit. First I start with control ROM. The control ROM contains the microcode sequences that define the operation performed by each of the machine code instructions. What's the meaning of this, guys? You remember friends, once you may identify this control ROM, that means to know the corresponding processor have a control unit type is microprogrammed control unit. Microprogrammed control unit. I think everyone aware of, there are 2 types of control units we use in our systems. One is a hardwired control unit and second one is microprogrammed control unit. So if you go and use microprogrammed control unit, especially is in CISC systems, that means where we may found more number of instructions in the instruction set, in such CPUs we may found this microprogrammed version of control unit. So your 80386 have more number of instructions, It can do more number of operations, so that your 80386 is comes under a CISC processor, so that it has a control unit is a microprogrammed control unit. Once your control unit is a microprogrammed control unit, in that control signals are generated by execution of some micro instructions. In a micro instructions are stored in a control memory. Those micro instructions are stored in a control memory. That means in execution of each and every machine instruction, internally a sequence of micro instructions are executed for generation of different control signals. Those are micro instructions I was stored in a memory called control read-only memory. So that is an important thing about this. And next, it reads and decoded instructions from the instruction queue and performs the operations that are specified based on what are the micro instructions I was reading from my control read-only memory. And next, the multiply and divider logic implements bit shift and rotate algorithms to complete the operations in minimum time. So one thing is very clear, guys. Already you have ALU. ALU means arithmetic and logical unit. That means that unit can do both arithmetic operations as well as logical operations. But here you may identify that a special multiply and divide unit also. That means here you have to think one important why we have a separately multiply and divide circuits are exist. Already your system have ALU. The reason for this is, friends, compared to other arithmetic operations, your system will take much more time to do either multiplication as well as a division. In order to reduce that time to do a multiplication or a division operation in your processor, what I have to do is I will go and take a separate, a dedicated multiply and a divide circuits. This multiplication and division I do with the help of a dedicated multiplication and division unit. In that case, I will go and use a simple concept that is bit shifting as well as rotating algorithms. That means for making out that multiplication and division circuit, I took the help of multiply and division operation I do with the help of bit shift and rotate algorithms. I think you are aware of using both algorithms for doing a multiplication, as well as we are we learn about sign numbers division in case of computer architecture and organization. So those algorithms are used for making of this dedicated multiply and divide circuits. So apart from multiply and divide, your ALU can do some mathematical operation like addition, subtraction, addition with carry, subtraction with a borrow, incrementation, decrementation, as well as it will do a different logical operation like logical and logical or logical XOR, complement, all these things it will do it, right? And thereafter, it may have another important thing. During execution of an instruction, it requires, during execution of an instruction, it requires the segment and paging units to generate operand addresses and the bus interfacing unit to perform a read or write bus cycles to access a data in memory or an I/O device. So what your execution unit can do? In order to do an execution of an instruction, sometimes it will go on to get data from internal registers. It is not possible for all cases. Sometimes to do an operation, that means to do execution of an instruction, you need a data from either memory or from an I/O devices. At the time, what your execution unit can do is, it guides our segmentation unit as well as the paging unit for to go and get a data from memory, and it will go and guide both those things to go and get a data from an I/O devices with the help of bus interfacing unit BAU. So that's important. Your EO has 8 general purpose registers and 8 special purpose registers used for handling of data and calculation of offset addresses. So in your execution unit, you may found 8 general purpose registers and 8 special function registers. What are GPRs? This is very important, guys. What is general purpose registers? You remember, friends, if you want to call a register is general purpose, the register is suitable to hold either data or an address or a results temporarily. That means the usage of these registers purely depends on user interest such registers we consider as general purpose registers. And one more thing, in so many processes you may identify that general purpose registers. Generally the general purpose registers we can call as scratch pad of that corresponding processor itself. That you have to remember, friends. In addition to that general purpose registers, you may also find some special function registers. The name itself indicates these registers are used for some special purposes. So those are helpful for me handling of a data as well as calculation of offset addresses. So that's the use of this. And one more important thing is your execution unit have a barrel shifter. So what this is? This is a shifter circuit. It can shift the input data n number of times in a single clock cycle. I repeat my statement. What a barrel shifter can do? It can shift the input values some n number of times in a single clock cycle. But if you go for normal shifter, in order to shift your input data by 1 bit position either left side or a right side, it takes 1 clock cycle. If I want to do a 4 shifts by using a normal shifter, either to left side or right side, definitely I need a 4 clock cycles. But if you are coming to the barrel shifter, you need not be faced that type of problem. Here the thing here is your barrel shifter itself, it can shift either directions n number of times in a single clock cycle. So that I do the shift and rotation operations at a very faster rate by utilization of shifter, barrel shifter. That was happened in case of 80386. Fine. And next one is the segmentation unit. What is the segmentation unit is? Generally, the segmentation unit plays a vital role in 80386, guys. Already we are aware of our segmentation concept in 8086. Your 8086 supports 1 MB of memory. That 1 MB of memory we divided into 16 different segments. By doing of our segmentation, we have a different advantages like security levels are increases, as well as we can go and do a parallel processing, and we can also go and use effectively the available memory space. All these advantages we are getting from that. The same concept we are adopting in 80386 also. But if you remember the features of 80386, your 80386 can support a memory of a size 4 GB. And we know that. And it also supports a virtual memory of size 64 terabytes. So here important thing is the available 64 terabytes of virtual memory can be organized into different segments. Each segment size is equal to 4 GB. That means at any instant of time, if you go and observe your system itself, you may found one segment of size 4 GB as your physical memory. So here the segmentation concept plays a vital role, so that segmentation unit we have exists in case of 80386 memory management unit. It offers protection mechanism in code in order to protect the code or data present in the memory from application programs. So what's the use of this? This segmentation unit provides a protection. It provides a protection mechanism for a code as well as the data from our application programs. That means every system has some system files. In the system files we have a programs as well as a constant data that exists. Those are must needed for us to proper run of your system itself. Those programs are completely different from our application programs. What this segmentation unit can do is it offers a protection for the system files from our application programs. It gives 4 levels protection to the data or code present in a memory itself. So here we may found 4 levels of protection. Those what we can call is privilege levels. That is a privilege level 0, privilege level 1, privilege level 2, and then privilege level 3. So for better understanding, I can go and use this. This is PL0, that means privilege level 0. And this is the next one is PL1, privilege level 1. And this is nothing but next privilege level, that is privilege level 2. And this is nothing but a privilege level 3. So these are my 4 privilege levels. These are my 4 production levels. Now see here guys, always this PL0, that is the privilege level 0, have a highest priority compared to PL3. What means PL3? PL3 is privilege level 3 have a lowest priority. So now you remember friends, if a person is able to access the information the present in PL0, he is eligible to go and access the information either from PL1, PL2 or PL3. I repeat my statement. If a person is able to access the information from this PL0, the same person is able to access information from PL1, PL2 as well as PL3. If a person is able to access the information from PL1, he was unable to access the information what is there in PL0. But he is eligible to go and access the information from PL1, PL2 and PL3. If you observe in this scenario, the person who are eligible to go and access PL1 is never unable to access the information present in PL0. That's why the PL0 information was more secure. And next thing is, if a person is able to access an information from PL2, he was able to access only information from PL2 as well as PL3. But he is never going to access an information from PL0 as well as PL1. And similarly, PL3, the person who can access the information at this level, we can't access the information either from PL0, PL1 and then PL2. If you are observing this case, our information was more secured in case of this particular 80386 case. So that's what our segmentation unit can do. So this is what I'm saying. And next one is paging unit. The last unit in our 80386 architecture, which is a paging unit. So what is paging unit? Paging unit operates only in protected mode and it changes the linear address into physical address. So now important thing guys, you remember, if you know the features of 80386, one of the features is related to operating modes. At the time, I clearly told you that 80386 can operate in 3 different modes. One is real mode, second one is protected mode, and third one is virtual 86 mode. So here we can clearly say that this paging unit only operates in the protected mode operation of 80386. We never want to operate this paging unit in real mode operation of 80386 or virtual mode operation of 80386. It is only using a protected mode operation of 80386. In that one, what it do? This paging unit have a task. That task is, it is used to convert the linear address into physical address. The linear address, the address which is supplied by segmentation unit. In the feature specifier clearly mentioned that it has a virtual memory of a size of 64 TB. There we are getting virtual addresses. Those virtual addresses are converted into a linear address that is done by your segmentation unit. And later that linear address is converted to physical address that is done by your paging unit. So that here you have to remember friends, your paging unit only operates in protected mode, that is number 1. And number 2 is, the task of this paging unit is, it is used to convert a linear address into a physical address. That is the second. And third thing is, the segmentation unit controls the action of paging unit. No. Because the segmentation unit only can supply a linear address to the paging unit, so that your segmentation unit controls the paging unit. And next, the paging unit supports multitasking. So if you want to understand this, just you need some idea regarding to operating system concepts. So where I was using a paging concept is, in a paging concept, I divide my program into number of small partitions. Each partition we can call as a page. And similarly, memory also divided into small partition. Those we can call as a frames. And we want to keep all the pages of a program in a main memory. What I have to do is, only the pages which have a demand, those pages I keep on to main memory. Rest of the things I placed on to secondary memories. Due to this, what happens is, I can go and assign a more page. I can go and assign the memory space for more number of programs. So if I identify some difficulty in execution of any program, I immediately shift it to execution of second program. There, if I found any error or if I found any difficulty, then I will shift it to the next. So that the paging unit supports a multitasking. This is so because the physical memory is not required to hold the whole segment of any task. That means we need not keep all information of current executing program in the current segment itself. So that's the meaning of this particular one. So despite only that a part of segment which is needed to be currently executed must be stored in that memory whose physical address is calculated by paging unit. That's what I'm saying. I need not be copying whole information, only what are the portion that I would need it, that I was keeping on to my main memory, and rest of the things I placed on to the secondary memory. So what are the pages I keep on to main memory? For those pages accessing only, I have to go on to convert a linear address into physical address. This result reduces the memory requirement and hence this frees up memory for other tasks. Yes, absolutely. Once you need not be stored everything of current executing program or a task in my main memory, automatically I can go and give a chance to other programs or other tasks. So that's the meaning of this. Thus like this, we get an effective way for managing the memory to support multitasking. Absolutely. So this is what my paging unit can do. So this is about the architecture of 80386. I hope everyone enjoy this and everyone understand this concept. So thank you for patient listening. We'll see you on next class. Thank you very much.